Hello, everybody. Today's topic will be the black hole, and well, not the X-ray. Sorry again. I'm going to try and do this after this video clip. So, but this one will be about the black hole because it's all over the news, and they won't give you the truth. And I'm gonna give you my explanation, and I think it is what it is, but and I'm very convinced that they know what the black hole is, but they just want to give you some blurry pictures and say something different. So I'm going to show you a BBC, what I found on the BBC page, and they are going to explain what they say the black hole is. So, you have to watch this video clip first, and then I'm going to explain my version.
This image is new. It's the image of the supermassive black hole in the heart of our galaxy, Sagittarius A star. And what are we looking at? We're looking at a very bright ring, which is quite similar to the black hole we saw 3 years ago. But it's also quite different because we see blob structures inside. And these blobs are very hot regions of the black hole and the environment around it, which are emitting radiation. And we see a dark center, and the black hole lives in there. That's what we call the black hole shadow.
Is it offensive to call it an orange donut?
we actually affectionately term it the donut in the collaboration. So the choice of color orange is an aesthetic one.
And so the blackness in the middle, that's where this gravitational mass is absolutely squeezed in. Around the outside, so this is all hot gas that's swirling around this black hole and heating up, is that right?
That's right, yeah. So this gas is circulating around the black hole, it's orbiting it, and it's slowly moving inwards. And as it moves inwards, it gets really hot and bright, and it radiates across the entire electromagnetic spectrum. And what we've done is we've made an image using radio waves.
And the gravity, these strengths affects light itself. Is the light itself being sort of bent and distorted by the black hole?
That's a very good question, and the answer is yes. So black holes, by definition, have an event horizon. So gravity is so strong around a black hole that not even light can escape this event horizon. So when you're close to a black hole, which is what we're imaging in this image that you're seeing today, some of that light can actually orbit the black hole multiple times, and so you can form like a ring of light in the image. It's not a physical ring, it's a gravitationally lensed light from this swirling matter. And so part of what we're seeing, although it's very blurry at the moment, is this gravitationally lensed ring in the image.
Now, I was confused. The last time you imaged a black hole, it was around in the middle of the galaxy M87, which is an enormous distance away. This is much closer. It's still 27,000 light years, but it's a lot closer. Why was this one harder to see than a distant black hole?
That's a very good question. That's the question that actually everybody's asking us as collaboration. So this last one was 55 million light years away. It was around 6.5 billion times the mass of the Sun. So its angular size on the sky was actually about the same as Sagittarius A star that we're looking at today. But the reason why this one was so much harder is because this black hole is 1,000 times smaller in mass, which means that plasma that's orbiting the black hole, hot matter, it can orbit 1,000 times faster. So you're seeing things change on a timescale of seconds to minutes. So it's like trying to take a picture of a bullet whizzing past you rather than a parked car, for example, in the case of M87.
So each frame was a kind of flicker.
Yeah, exactly. It's just every time you look at it, it looks very different for this black hole. And the other reason is we're looking through all of the Milky Way towards the center. So we're having to deal with stars and dust and gas, and they blur and scramble the image. So we have to mitigate those effects too. That was a unique challenge.
And with that fast-moving gas, is that one of the things that you're sort of learning about now? I mean, it's not just a picture. Presumably, this is some sort of deep astrophysics you're getting into as well.
Yeah, so exactly. So this gas that's swirling around, it's changing very rapidly, and we don't quite understand the state of it. We know it's very magnetized, it's extremely hot, it's millions of degrees, and it radiates across the entire electromagnetic spectrum. So you can detect radio waves like we did, but you can detect everything up to X-rays and even gamma rays from that.
And so you're going to keep looking?
Yeah, we're going to keep looking, we're going to get sharper images. In time, we're even going to make movies, and we'll see how this black hole is feeding on that matter in real time. And this will really help us understand much better the connection with this black hole and the rest of our galaxy.
Okay, so it's very blurry at the moment, enormous distance away. They have to tell you that it's very far so they can take like sharp pictures. And it's extremely hot, gas swirling around, changing rapidly. We don't quite understand the state of it. Very magnetized, extremely hot. Covered that one already, but okay, it radiates across the entire electromagnetic spectrum. You can detect radio waves. Oh, electromagnetic spectrum, because we live in an electric magnetic universe, but they won't tell you that. No, they just have to like give you some fake information, and then yeah, you can detect radio waves like we did, but, and you can detect like everything, like X-rays. There you got the X-rays and gamma rays. From there, you can detect like all that sort of stuff, and then they say, well, in the future we might have sharper images and movies. They will have movies, but they already have sharper images, but they won't give you the full information, of course, directly. They have to delay all that sort of stuff. So on this image you see the black hole on the layer of the stars and the Milky Way. If you watch the video clip of Gothic Vlamste about the layers, so you can understand that there is a layer of stars, and there is a layer of the moon, and then you have a layer of the sun. Uh, but they all have the black hole. The black hole actually. The sun got the black hole passing by at the sun eclipse, and the moon got the moon eclipse. But it's not like they say, oh, the moon is covering the sun. No, it's the black hole. So the black hole is also on the layer of the sun and on the layer of the moon and on the layer of where the stars are. So it's like an onion, like Gotthard Plumster said, and that is where the black hole passes by. So the black hole passes by on all the layers, and that makes the sun eclipse, the moon eclipse, and the stars eclipse. So what is the black hole? Where is it coming from? Well, this is the black hole. It's on the North Pole. Now you're saying, well, it is on the ground. Why it's not in the air? But what you see in the air, so in the sky, is what is below. So the only spot on Earth uh, that is not appearing on the sky is that black hole, because it doesn't have light, so it is black. So the black hole is exactly what you see in this image. This is why the sky has a black hole. It's because it's on Earth. It's on the North Pole, and the radiation that is coming from there, that is what well, that is what is causing the black hole up in the sky. Because the rest you can see the land up in the sky, the craters, and the bigger Earth you can see up in the sky. Only this spot you can't see, because it doesn't have matter, so you can't see it in the sky, and that's why you have the black hole. They won't tell you that, like this image. They will say, well, this is fake, and but this is actually what you have on the North Pole. But they won't tell you what the meaning of this hole is. And well, That is what I'm trying to explain, but maybe I can't explain it in a good way. But I hope you can understand that this is causing the black hole. So, like this image from NASA, it is the black hole on the North Pole, and that black hole is projecting in the sky as the black hole you see, like on those blurry images they give you. But this is causing the eclipse, and this is causing the black hole. So as above, so below, and like you have the craters that are projected in the sky as stars. Also, the black hole is also projected in the sky, like the bigger Earth is also projected in the sky, and also the black hole, and that one is like traveling around the plasma screen as that mysterious black hole, and you have like the mini black holes on the sun too as sunspots, and yeah, they just want to give you a whole different information. And I got some bonus um, about what I think the, the Earth is all about. I think it's just like the Matrushka doll. It's an Earth in an Earth in an Earth. And yeah, that is what I'm going to explain you in the next video clip. Um, like we are fractals. The Earth is also a fractal, and that's why you have giants on Earth. Oh, there have been giants on Earth, and we are just a smaller version. Okay, I hope that you understand a little bit what I'm trying to say, and maybe see you in the next video clip. That is going to be about the Mandelbrot set, because I think the universe is a Mandelbrot set, and I'm going to explain you about the X-ray. Okay, thank you for watching. Till next time, bye.